Okay, so this says consider the process shown below. In the process AB and BC, 3,600 joules and 2,400 joules of heat are added to the system, respectively. Find the work done in each of the process AB, BC, AD, and DC. Find the internal energy change in process A, B, and C. Find the internal energy difference between C and A. Find the total heat added in the process. Oh man, we'll be here forever. From the information given, can you find the heat added in process AD? Why or why not? Okay. Alright, so let's do it one piece at a time. And I'll have to do it fairly quickly. A. So work done in various processes. Find the work done in each of the process A, B, D. A, B, B, C. Okay. For the process AB, work is 0. It's an isochoric process. For the process BC, the work done is 5 atmospheres is the height times the width, which is 4 liters, and each liter is that many meter cubed. So 22,000 joules. For the process AD, the work done is P delta V equal to 2 atmospheres, and delta V is again 4 liters. So the process AD, the work done is again 800 joules. And for DC, the work done is 0. So we've calculated the work done for each of the processes. Okay, so the point of this problem will be the following. See, you're going from here to there along 2 different paths. The work done along this path is 2,000 joules. This plus that is 2,000 joules. And work done along this path is 800 joules. So the work done along this path is less than the work done along that path. Change in energy will be the same for the same path. So the heat absorbed along this path will be greater than the heat absorbed along that path. That'll be the point. Okay? So work done and heat absorbed is path dependent, but change in internal energy is path independent. Okay? Okay, find the internal energy change in processes A, B, and BC. A, B, and BC. Okay. So change in internal energy is Q minus W. For AB, they tell you you absorb 3,600 joules of energy for process AB. Okay. And the work done was 0. So for BC, The work done was 2000 joules, so 400 joules. All right, so what we have found is in going from here to here, your internal energy increased by 3,600 joules. In going from here to here, your internal energy increased by 400 joules. So in going from here to there, your internal energy increased by 4,000 joules. And it doesn't matter how you get there. Your internal energy will increase by 4,000 joules. Okay. All right, then what is it that they want? Part C. Find the internal energy difference between states C and A. So change in internal energy in going from A to B, or let me write a better notation. Let me use a better notation. Change in internal energy going A to B plus change in internal energy going from B to C. And this was 3,600 joules plus 400 joules, 4,000 joules. So we are explicitly saying that in going from A to C, your internal energy increased by 4,000 joules. Okay. And what else do they want? Find the total heat added in process ADC. Okay. D. We know A to ADC. Along that path, the total heat added along that path is change in internal energy is 4,000 joules. Because in going from A to C, it doesn't matter what path you took. The change in internal energy is 4,000 joules. And how much work was done? There was no work done here, only work was done here. And work was done, that work was 800 joules, which is right there. Work done along path AD was 800 joules. Yep. Yeah. We don't know the energy of, these are all differences. We don't know what the energy in state A is. We don't know what the energy in state C is. In going from A to C, we added 4,000 joules. That's what, it's a difference. All right, so plus 800. So in going along that path, you added 4,800 joules of heat. And remember, in going along this path, just to show you that the heat added here was 3,600 plus 2,400 equal to 6,000 joules. So along that path, you had added 6,000 joules, which we didn't calculate, but along this path, you added 4,800 joules. So again, the whole point of this problem is we are showing you work done and heat added are different along different paths, but the change in internal energy is the same. Okay. Okay, so from the information given, can you find the heat added in the process AD? Can we okay, so Okay, so I guess not. So we know the heat added. We know the heat added for the entire process. We know the work done. Well, we don't know the internal energy of state D. We know the work done here, so I guess not. Okay, so for AD, for process AD, to find this, we need to know, we know the work done, except that we don't know the change in internal energy. So we cannot. We know W, but not delta E. So Q cannot be found. And that's for just this process, for AD, for the process AD. Okay. All right. So this is using the first law. Okay. Any questions on that?